In the last video, we discussed the formulas for derivatives of exponential and logarithmic functions. Today, we're going to use these formulas to solve some problems. So, for the exponential functions, we found that derivative of e raised to power x is simply e raised to power x, and derivative of a raised to power x. So if you have some other base, would be a raised to power x times ln of a. Alright, so for the first problem we have we need to find derivative of e raised to power 5x. So first we notice that this is different. So the variable is different from what we have in the power, so it's different from x, so we need to apply the chain rule. So derivative of e raised to power 5x is e raised to power 5x, and by chain rule derivative of 5x, we need to find that. So derivative of 5x is 5, so we got the answer would be 5 times e raised to power 5x. So remember, you need to apply chain rule whenever you have a different power, which is different from x. So let's try the next problem. Again, similar thing. So derivative of e raised to power sine x. We notice that we are taking the derivative with respect to x, but in the power we don't have only x, we have sine x. It means we need to apply chain rule. So derivative of exponential function is the same exponential function, but if the power is different, we take the derivative of power. So we got e raised to power sine x. Derivative of sine x is cosine x. So we have cos x times e raised to power sine x. So that is our answer. Next, we're going to try to find the derivative of two different logarithmic functions in part C and part D. So it looks like they are similar problems, but they're really not. They're different problems. So if you look at part C, so what we have here is ln of 1 minus 2x cubed. So in this case, the power 3 is only on the expression, so only on the expression 1 minus 2x. So ln is our outside function and then power is our inside function. So whenever we have some logarithmic problems, it's always a good idea to make it a little bit simplified using the properties of logs. So if we first use this property of log, which is ln of x raised to power n is equal to n ln x. So let's try to use this property. So we can rewrite our expression as, so bring the power in front. So 3 times ln of 1 minus 2x. So now it becomes a simplified problem. So if we take the derivative now, so we will see that it will become lots easier to work with. So 3 is just a scalar. So derivative of ln of 1 minus 2x. And again, we know that derivative of a ln function is 1 over x. But if you have a different expression inside the ln, so you need to use chain rule. So it's different than x, we will use the chain rule. So dy over dx is 3 times, so first for the ln 1 over 1 minus 2x, but by chain rule we need to take the derivative of inside. So dy over dx is equal to 3 1 over 1 minus 2x, and the derivative of 1 is 0, minus 2x is minus 2. So overall we got 6 over 1 minus 2x as our solution to this problem. Moving on to the next part. So we have to be very careful. So we should distinguish between the previous problem and this problem. So in the previous problem, we had ln of 1 minus 2x cubed. But in this problem, the entire log function is cubed. So in fact, you would be surprised to know that this means the same thing. So ln of 1 minus 2x, the whole thing cubed is same as ln cubed 1 minus 2x. But this is the preferred notation, but essentially they are the same thing. So this is the preferred notation. Let's try to figure out the derivative of this function. So our given function is y is equal to ln of 1 minus 2x. So if you want, you can write this as this. And in this thing, we will notice that the outside function is the power function and inside function is the log function. So it means when we take the derivatives, first we need to apply the power rule for the derivatives. So using the power rule, when we take the derivative, so power comes down, power is reduced by 1, and then we take, by chain rule, we take the derivative of inside function. All right, so dy over dx is equal to 3 times, so I'm just going to write this in the preferred form, ln square 1 minus 2x, and derivative of ln of 1 minus 2x with respect to x, since inside the log we don't have x, we have different algebraic expression. So it means when we do the derivation, we need to use the chain rule. So we get 1 over 1 minus 2x, and by chain rule, the derivative of 1 minus 2x, so we get dy over dx is equal to 3 times ln square 1 minus 2x, 1 over 1 minus 2x, and derivative of 1 is 0, derivative of negative 2x is negative 2. So overall we got, so we can combine 3 times 2 is negative 6, ln of 1 minus 2x, the whole thing square, over 1 minus 2x. So please carefully notice the difference between the part C and part D. And then decide on what is your outside function, what is your inside function, and proceed to take the derivatives accordingly. All right, so next we are going to discuss find the derivative of y is equal to ln of 2x plus 8 over x squared plus 7. So as I said earlier, sometimes the easiest way to do the ln problem is to use the properties of logs if you can. So if you recall, we have a property of log. So if you have the division of two expressions inside the ln function, so you can write this as subtraction of two expressions. So ln of x over y is equal to ln of x minus ln of y. So we're going to use the exact same thing here. So we're going to rewrite our function as ln of 2x plus 8 minus ln of x squared plus 7. And now is a good point when we are at a point when we can take the derivative on both sides. So taking the derivative on both sides with respect to x, it means we take the derivative of each term with respect to x. So taking the derivative of each term with respect to x. So dy over dx. Again, we know that derivative of ln x is 1 over x, but since the input is not x, it's 2x plus 8, we need to apply chain rule. So first derivative of ln function is 1 over ln function, and then by chain rule you need to take the derivative of 2x plus 8. Similarly, in the next one, again, we have x here, we have x squared plus 7 here. So first we take the derivative of ln function, which is 1 over ln of the function, and then by chain rule take the derivative of x squared plus 7. So we got, okay, so derivative of 2x plus 8 is just 2, so you got 2 ln of 2x plus 8. Similarly here, derivative of x squared is 2x, and we got 2x over ln of x squared plus 7. So this is what we got in this case. So this is how we applied the formulas of derivatives of logarithmic and exponential functions. So in the next video, I will discuss an application problem. So please do watch the next video.